In this video, I'm going to demonstrate that what we know now could obscure the path forward, and I'm talking in terms of scientific technological advancement. In fact, let me put a more fine point on this. It's what we believe could obscure the path forward, because it's not necessarily true that what we know is the truth. And this comes from an old expression I heard when I was a kid that basically said, if all you have is a hammer, all of your problems begin to look like nails. Now, I didn't understand this as a kid. It was sometimes later when I heard that physicists believed that the sun was a big burning ball of anthracite coal. Now you think, well, why would they think that? Well, in the 1800s, when they believed this, they didn't understand nuclear power. All they knew that created heat and light was fire. So if all you know is that creates heat and light is fire, then it follows that the sun must be a big ball of fire. And this shows how what you know now can obscure the truth going forward. This is Distinti's Rules of Scientific Acquisition. This is the 8th video, The Knowledge Traps. In this video, I'm going to show you how our existing knowledge can obscure the path forward. Included with this is the 20 and 21st Rule of Acquisition. These are not knowledge traps, but they're related to knowledge. And these are appended at the end because they needed a place to go. So now that we understand nuclear power, we believe the sun is a big fusion ball. But this is just as silly and anemic as the burning ball of coal idea, because it's one way. In other words, in the burning ball of coal example, when the coal burns out, the sun is dead. In this example, when the hydrogen fuel is expended, the sun is going to die. And one thing I've learned about nature is that Mother Nature loves to recycle. And this one-way process for the sun, in my opinion, is extremely anemic. And ethereal mechanics shows that there's a recycling process going on here, and the sun may in fact be trillions of years old as opposed to billions of years old. In the past, what we knew affected what we believed the future would look like. In Jules Verne's day, they didn't have anything other than guns, really, or rockets to put things into space. And since rocket technology was very primitive and gun technology was very advanced, they assumed that if we went to the moon, it would be in a capsule that would be propelled through gunpowder to the moon. Now, it's interesting that this first story of the trip to the moon isn't actually true. In the Wikipedia article for this, they do cite other previous examples of trips to the moon, but the one they missed, in my opinion, is the best one. It's from Edgar Allan Poe. And in Poe's story, his person went to the moon on a balloon. And you say, well, there's no oxygen. Well, that goes back to the burning ball of coal. In Poe's day, they believed that the sun was a burning ball of anthracite, so there had to be oxygen in space. And therefore, a trip to the moon should be possible because there's air. Now, in Poe's credit, he understood that as you go up in altitude, like when you go to the top of Mount Everest, the air becomes more rarefied. And so his balloon was equipped with equipment to concentrate the air so that the human could survive on a trip to the moon. And before they invented gunpowder, if you wanted to go high up into the air, you'd have to actually build a structure. This is the Tower of Babel from Wikipedia. So this shows how our path forward is actually limited by what we know now. So our bridge to the future, the bridgehead to the path forward, is from what we know now. And that is the problem, because if our existing knowledge is faulty or it's missing, or even though it gives us correct answers, it might be a doppelganger that gives us the right answers for the wrong reasons. And this just popped up on my feed today, where the physicists believe that a theory of everything can't possibly exist. I'm just astounded how stupid physicists. I am sorry. You should never say bad things about people, but my friends, there is an extinction level event coming. It's just a matter of time. And these physicists are just dragging their feet, and already they're giving up. They're completely useless. As a matter of fact, I just thought of, I think I know where the missing link of human evolution went. They all became physicists. I'm sorry, this is extinction level stupidity. And you have to remember that before the Wright brothers flew, the physicists of the day believed that heavy-air flight was an impossibility. They've been proven wrong so many times that, well, I'm going to keep on going the video, and I'm going to let you decide where you want to go with this particular fragment. And here's a classic example of where what we know now stagnates our progress forward. And this is an example from the movie The Race for the Double Helix. They say the movie is 1 hour and 37 minutes. It comes in 2 parts, but if you add up the time for both parts, it comes out to 1 hour and 46 minutes. You don't have to watch the movie. I'm going to save you from that torture, because the first hour and a half of this movie is Jeff Goldblum's character nerding out how nothing makes any sense, nothing adds up. And the reason why is they had the wrong models. In fact, just before this scene here at 38:30, at 37:40, Jeff Goldblum says, "This thing is either a monster of complexity or it's so simple we are missing it." My friends, that is the classic thing of what happens in science. We are looking for pyramids when a pine box will do. So at 38 minutes into part 2, nearly an hour and a half from the beginning of the movie, this guy that's humbling along hears these Jeff Goldblum and the other guy, being beside themselves with how horrible this is going. He looks down at them and says, "No, it's all wrong. Everything you got here is wrong." In other words, they had the wrong models. And he said, "Where'd you get these models?" And they said, "A common textbook." And then his next expression was, "Oh, it's one of those guesses that have been repeated so often it has the status of fact." So after he gives them and draws the correct model for them, so within 20 seconds, they've already got out the papers, the scissor, and the glue. And within 2.5 minutes, they've got the model of DNA all figured out on the paper, how all the pieces fit together. So in 2 minutes, they solved the complete DNA problem, and the last 12 minutes is basically them gloating and celebrating. So if they had the right models to begin with, the movie would have been less than 14 minutes. And this is a common problem in science. We get stagnated because what we believe to be the irrefutable truth is not. And that's what's happening with science now. That's why they're giving up, because they can't make their crap work. And instead of claiming that they're failures and they're stupid, what they're going to claim is, "Oh, it's just not possible." That's the easy way out. That's the coward's way out. I'm sorry to be, it's just blowing my mind. They could have plagiarized me years ago. They're not even smart enough to do that. It's just astounding. I'm going to keep going. Sorry, it's just that video coming in today just really got me. So the 6th rule of acquisition is prior knowledge is problematic because it could be wrong. You could have missing pieces. It could be a doppelganger. If all you know is fire, you will see anything that generates heat and light as fire. Nothing we believed in then has persisted to now. And what we believe in the end, the theory of everything, will not look like anything we know today. Well, is not likely to consist of anything we believe now. Obviously, it can't, because they're giving up on what we believe now, except for us at the theory of mechanics, of course. And 6.4, unfortunately, our existing knowledge is the bridgehead to the path forward. Next, we're going to talk about higher and lower knowledge, and this will lead into the higher knowledge trap. What I've talked about in the past is that what we see at our level, this phenomenon, is usually made up of some lower level mechanism. And I'm representing the higher levels at the top of the puzzle and the lower mechanisms by all the gears that would run. This is just an analogy. And then if we start peeling away the gears, below the gears, you will see another layer of detail. And this layer will look nothing like this layer, and this layer will look nothing like this layer. And this is the concept of going down the rabbit hole. And so I've started to mend this diagram from a lot of previous videos. I'm calling this the rabbit hole diagram. And at the top, we have the higher knowledge. As we go down the levels of the rabbit hole to get to the lower knowledge, that's called going down the rabbit hole. And one of the things we've observed from all the things we've done before is that when you get down to the bottom of the rabbit hole, as you go toward the bottom, that's where you go to least complexity. because only things with lower complexity have more applications, have more degrees of freedom. So you have more degrees of freedom going down and less degrees of freedom going up. We're going to discuss that complexity, simplicity in the next video in more detail. Let me show you the rabbit hole diagram of computer science. So at the top, there are infinite possible types of computers. That's at the top of the champagne glass here. And these computers are made of subcomponents called processor, storage, and peripherals. And there could be lots of various variations of each of these. And each of these components are made of by lower level structure, like flip-flops and decoders and shifters. And there's a couple others here, I didn't mention them. All of these lower level logic gates, constructs, can be constructed by somewhere between 3 and 5 basic logic gates. An AND gate, NOT gate, OR gate, NOR gate, NOT gate. There's maybe some others in there you could add in. And all of these are based on the simple idea of processing 1 and 0. And this right here, 1 and 0, is probably the bottom of the rabbit hole. There's nothing below this except possibly, well, how do you represent 1 and 0 with a voltage or a current or a whatever? But as computer science, we'll cut that off at the basic building block of computer science. And let's look at the rabbit hole diagram of chemistry. This is using legacy. Okay, we're going to show a problem with the legacy here. So at the top, you could have virtually infinite number of compounds that are created by less than 100 or so elements. And these elements are all created by 3 subatomic particles, the electron, the proton, and the neutron. Well, what's below this level? Well, if you ask physicists today, they have an explosion of complexity. And this does not fit the rabbit hole diagram. And I think this is one of the reasons why they can't go forward. So if we do the rabbit hole diagram with ethereal mechanics, okay, you have your compounds, but there's more detail. You also have the ability to create unstable and ionic variants. Even the elements, even though there's 100 plus, there's also unstable, ionic, and isotope variants that need to be considered, because these isotopes can go into these guys as well, and there's slight differences. Okay, from these elements are created by 5 stable subatomic particles in ethereal mechanics. That's the electron, proton, neutron, positron, and I'm going to call this the nulltron. And we talked about these in the standard model of ethereal mechanics. These are only 5 stable. The other guys over here, the up quark, the down quark, and all the neutrinos, this is garbage. This is garbage left over after you collide 2 things. A neutron, where one of the electrons in the neutron becomes loose, and becomes a hydrogen atom. But then the hydrogen atom will want to pair up with maybe another neutron to become deuterium, or another hydrogen atom to become hydrogen 2. These things always like to pair up. So even though the positron, people say, well, that's not really stable. Yeah, it's not stable because it's dying to be into the pants of an electron to form a neutron, or possibly 2 positrons to form a proton. So all of our matter up here are made from neutrons, because neutrons have 2 electrons built into them. And when one of the electrons becomes loosely held, it becomes a hydrogen atom. This is a lower level, this is lower energy state, and therefore it has less mass. Now, for those people that are adding these up, if you add up the masses of all these things that don't add, well, that's true. It doesn't add up for legacy theory either, but we have an explanation. We'll cover that in ethereal mechanics. So all of these 5 stable elements are created from 2 pretons. The negative preton is a negative 1/2 pretonic charge. It's not a Coulomb charge, it's a pretonic charge. And the positive preton is positive 1/3. That's why it takes 3 positive pretons to make a positron. It takes 2 negative pretons to make an electron. These are stable, but because they're highly charged, they want to try to combine to form any of these other more stable elements. Again, the stuff over here is the debris left over from colliders. This is your up quark, your down quark, and your neutrinos. These are unstable. They're not part of the normal pantheon. They exist temporarily when you collide stuff together. So over here, These particles on this are covered over here. The second and the third columns are just higher energy states of these. And these items over here are covered by the ethereal states, of the states of the medium, if you will. Because only physicists, the missing link in human evolution, would believe that if you smash two perfectly good pocket watches together, that the components that fall away from that collision are perfectly good components of a working watch, and you could reassemble two perfectly good watches from the debris field. Okay, normal people realize if you smash two perfectly good watches together, you just have a pile of junk, and that's it. Same thing when you take the mechanisms of nature and you smash the living bejesus out of them. You should expect useless debris that's just going to be reabsorbed by Mother Nature. So now that you understand the basic concept of the rabbit hole, we need to start getting into the rules of the rabbit hole. And again, science, we seek the truth. And that requires us to jump down the rabbit hole. And since we're starting always at the higher level and the job is to uncover and explore the lower levels, that is the objective. And from this, rule number 1 is the lower you go, the simpler things get. And as I showed you before, we go from virtually infinite to hundreds to 5 stable to 2 pretons. Is this the bottom of the rabbit hole? I don't think so. Number 2, expect that the levels do not look alike. What we see at the higher level does not necessarily hold true for the lower level or the lower level below that or anywhere below. So lower knowledge looks nothing like the higher knowledge. And let's explain that to you. So here's salt. Salt is a chemical compound. It's a crystal and it's clear. And it's necessary for life. So what are these subcomponents? What is the lower level of salt? Well, one component is chlorine gas. It's a gas, it's yellow, and it's toxic to life. That has no bearing on each other. There's no way that you could infer from here, from the properties here, that one of the subcomponents looks anything like this. The other component is sodium, which is a metal, which is also toxic to life, and it's opaque. There is no way that you can infer the properties of the subcomponent from the higher level. So you should never expect that what you see at the higher level has any bearing or relationship or anything in common with what constitutes it at the lower level. Third, higher knowledge is problematic. Because what if we know at our level is incorrect, which it's likely to be, or we have missing pieces, items that we don't know that we have that should be included at this level. In other words, missing effects. Or what if we have doppelgangers? We have models that look like and give us the right answers, but we don't know enough to know that they're wrong. They don't do it the way nature does it. They're fantasy. They're doppelgangers. That's what we call those. How are you going to start from that very bad foundation and try to derive down to uncover the lower levels, assuming that you could infer properties from the higher level to lower? It's problematic. And that's why deriving down is not how we're going to go. We're not going to take what we know at our level and try to do some kind of mathematical process to get to the lower level. Because A, we could have wrong models, we could have missing models, we could have doppelgangers that even though they give us the right answers, they're not the way nature does it. Also, what we learned in the previous rules of acquisition is that we have higher degrees of freedom at the lower, more fundamental level than we do at the higher level. That's the only way you can go from less complexity to more complexity, as if our simpler things have more degrees of freedom going up. There's another rule of acquisition in the following video called the simplicity-complexity duality, and that'll cover that concept in more detail. The other problem that we talked about is that derivations lose information, leading to ambiguities. So if you're trying to do a mathematical derivation to go down, you're going to lose information. So you're already hamstrung because you got lower degrees of freedom, and then you're going to lose more as you go down. It's just a problem. It's just problematic trying to derive from the upper level to the lower level. And finally, because you may have doppelgangers, missing information, or bad information, you put that into a mathematical process. Well, garbage in, garbage out. I just added that one to this video. So that's why it's not possible to derive down. And we can see the issues with the fundamental particles here. Because physicists believe that the mass is an intrinsic, immutable property of these particles. And that is not correct. These are not really the mass. These are the inertia. The mass of these particles are all the identical. They're all made of 2 negative protons. This is the same system at higher and higher energy states. The mass, the quantity of stuff, is the same. But the inertia, which is mutable, goes up with the energy level. So the inertia, what they call mass, is what we showed in a previous video. Mass is a doppelganger for inertia. Secondly, this Coulomb charge they show here is also a doppelganger. There is no Coulomb charge at this level. The Coulomb charge is synthesized by the protonic charge as these systems spin. Yes, they're spinning systems, and they synthesize through their spin, they synthesize the Coulomb field. So there is no real intrinsic Coulomb charge here. And secondly, physicists claim that the spin, showed by the 1/2 here, is an intrinsic property which violates the intrinsity tell. So what they're trying to do here is all of these properties are properties at the higher level. They're trying to say that these properties exist at the lower level, which is a complete failure. And it fails a lot of other rules of acquisition. So this is just out to lunch on. This is one of the reasons why they're quitting, okay? Because they don't have anything that's right here. And this brings us to the rabbit hole staircase problem. See, if you build a staircase, typically when you build a staircase, you build it from the bottom up so that you lay layers on top of layers. And so everything is built in compression, which is a lot easier to build. If you had to build a spiral scale staircase from the top down, you'd be building it in tension. In other words, you would have to have suspension cables, and everything would have, all the lower levels would have to be held up from the upper level. And trying to add stuff as you go down is a pain in the butt. And that's why you don't start at the top and derive down. You start, guess at what the bottom looks like, and then you derive up. So that is the rabbit hole synthesis rule. So whenever we do a rabbit hole, we don't start from the higher level constructs. We make a guess at what's near the bottom or a little lower down, and then what we do is then we derive up. And this is what Mendeleev did. Because at his level, a lot of the measurements of the elements were incorrect, and he didn't have knowledge of all the elements at that time. So he made a guess at the lower level of what the construct looked like, and then he used his cards. He played solitaire on the train until he got a model at the lower level that gave him mostly matching at the upper level. And then he looked at the ones that didn't match, and he had them remeasured. It turns out their measurements were wrong. And so his model proved that they had the measurements wrong and his model was right. Secondly, his model showed other elements that they didn't even know existed yet. And they went out and they searched for them and they found them. So that's why the importance of guessing down and deriving up. Again, that is the rabbit hole synthesis rule. And they did that for the double helix. Watson and Crick reasoned, in other words, they made an educated guess that the underlying structure of the DNA had to be a double helix. Now, and they did that long before they got the X-ray crystallography to confirm it, because Rosalind was holding on to that, or Rosie as they called her. And had they had the proper base models to begin with, they could have probably pioneered the DNA molecule before they got the X-ray crystallography confirmation. So, but essentially, they guessed down and they derived up. And so that is why deriving down is a problem, because you're going to start with this level here, and you don't know if any of these are wrong, any of these are doppelgangers, yada, yada, yada. So you don't know. And so what I did, so what you're supposed to do is you make a guess, and then you derive up. And then you say, oh, okay, well, these guys match what we believe here. And, well, these guys both give the same answer, but this does it a different way. So, oh, that was a doppelganger. And then you say, well, these guys were kind of muted together, and we have this new effect we had no idea of before. And that is what we found with both the DNA and the Mendeleev thing, is they guessed down and derived up. And that's what I did for the underlying models of rules new electromagnetism V5. Oh, this has been happening. Every time I close and restart, the equations get bumped upside down. I'm just going to plow through this. I don't have time to deal with this. I get so many other things I got to do, but these are flipped upside down. The math type thing is giving me problems. So anyway, so this is Coulomb's model. This is the components of magnetism. This is new electromagnetism version 3. And then so what I did was I made a guess that that's the underlying field of everybody. And then I derived up. Let's see. Oh, none of those are flipped upside down. Okay. And so we see here that Coulomb's model has an extra thing that's not in the original model. And so what we've had here then all this time is a doppelganger. A model that gives us reasonably accurate results, but at relativistic speeds, that's where the proper model gives you the correct answer. Over here, new induction matches what we got experimentally at the beginning. So new induction is validated. And then over here, we have a new model of magnetism, which has many more degrees of freedom than what we had before. And these were derived from classical theory. This is more complete. It's a matrix field and it's a spherical field. Now remember though, the important part to remember is our objective is not really to match other models. Our objective is to match nature. And all of these models have been experimentally validated with all the paradox experiments. And you say, well, you get all the right answers. Well, how do you know you're right? And it's like, I don't. But here's how we move forward. Okay, because getting the correct answers proves absolutely nothing. And we need to stress that to everybody. The only thing we have are models that gives us good answers. That means we have utility. It does not necessarily mean we have the correct models. Okay, because you can get the correct models from complete fantasy. So how do we know our models aren't fantasy? Well, that's it. We don't. So what we have to do, the path forward is we've got to use the models, the best models we can find, to improve our technology, improve our ability to measure, improve our ability to dive deep and go deep into space. And the more we expand our footprint, we're going to run into the counterexamples that would, in fact, prove our theories wrong. I mean, that's why we have the rules of acquisition, though, because hopefully we can weed out the other false positives using the rules of acquisition. But assuming the models all fit the rules of acquisition, the best we can do is expand our footprint until we hit the counterexample. And when that day comes, we have a wonderful parade. We have a national holiday. We have cookouts and beer and all kinds of things, and just celebrate, because now we can make progress forward. And that might feel confusing to some people, but think about it. If we don't have faster than light travel and we think we have the correct models that predict we can't go faster than the speed of light, well, we're stuck on this planet. And as I said before, extinction level events are coming. Whether it be a supervolcano, an asteroid impact, a mega plague, whatever, extinction level events are coming. And these physicists all of a sudden giving up is not helping us. Okay, so if our models predict that we can't go faster than the speed of light, then we're stuck. And so when our models gives us a wrong answer, that is happiness. Because that means if our models are wrong, our prediction that we can't go faster than the speed of light is probably wrong too. And this gives us an opportunity to move forward and possibly find a way to go faster than the speed of light. And then once we wake up and we brush off the hangover, we get back into our laboratory, and now we know where to look. The point of failure is the beginning of the path forward. See, we need to get people to understand that failure in science is forward progress. Because if we confirm what we already know, then all we're doing is confirming that we can't make it off this planet because we can't go faster than the speed of light. So we're dead. We're basically just sitting around waiting for the extinction level event. So failure is important. And what I've done is I've taken the old model of how I view all the components of ethereal mechanics together, which was kind of kludgy, and now I free-formatted them into the rabbit hole diagram. We'll talk more about this later. This is the frontier. This is the level where we're going to break down through into ethonics. Is there something below that? I don't know yet. These black spots represent things, little anomalies or things we don't know yet. Talk more about this later. So, rule of acquisition 10, which is a higher knowledge trap, or it's also known as the rabbit hole rules, is higher knowledge is problematic because it could be wrong. We could have missing higher knowledge, or a higher knowledge may actually be a doppelganger. And it's not likely that lower constructs will look anything like higher constructs, and vice versa, of course. And the rule of synthesis is you guess down and you derive up. You build the staircase from the bottom to go down the rabbit hole. Next, we're going to talk about rule of acquisition 20, the poor efficiency tell. See, what we have here is this blindfold represents that we do not have a template of what a theory of everything looks like. We do not know what the path forward is. We don't know how advanced or primitive our technology is right now. We don't know. And the purpose of this rule, the 20th rule of acquisition, is to come up with a way to judge just exactly how far down the rabbit hole, how good we are at any good time. Again, this is for our new scientific model. We're using justice as an avenging angel is our new science paradigm mascot. And again, her blindfold represents the same thing. So what is this magical way to judge how far we think we are gone? How advanced do we think we are? How deep do we think we've gone down the rabbit hole? Well, in every scientific phenomenon we see, and it doesn't matter if it's quantum entanglement or two charges, communicating through or two massive bodies communicating through gravity. We have all of these actions at a distance, whether it's magnetism, Coulomb charge, quantum entanglement. I don't believe in it, but let's just use it as an example. We can use it. When you change something over here, it affects something over here. You're basically transferring energy across the void of space. So energy seems to be the litmus test. And let's talk about energy in terms of efficiency. So if you take an incandescent bulb and you go through all the math, you find out that the old incandescent bulbs only turn about 2.2% of the electricity you pump into them into actual light. They're very efficient. They're very inefficient. And with newer technology, with the LED technology, we're getting much higher efficiencies. So as our technology improves, our efficiencies improve. Where else can we see this? Well, transformers are almost 90% efficient. The basic design hasn't changed in over 100 years. Even though new electromagnetism proposes a different theory on how they work at the lower level, the upper level performance hasn't really changed. So either theory is wrong or one theory is right. We don't know. It's possible. Definitely a doppelganger in there somewhere. Nuclear power plants. Well, the fission power plants that we have, if you go online and look, are only about 2% efficient. Well, that's very inefficient, is it? So of all the energy that's in matter, we're only taking 2% out. There's something wrong with this. And fusion, well, we don't actually have a working one yet, in spite of all the claims of progress that have come out in the news over the past year or so. So until we actually see a working fusion plant, I'm putting this at 0% efficient. Jet engines. Well, if we look at, this is from MIT. I think they're proposing new engines up here. So these might be overly optimistic. So let's just look at the 777 engine. And that's right around here, which works out to be about 36%, 37% efficient. Okay, and then you can look at the efficiency in different ways, but overall efficiency is where I'm looking. That's 37%. Look at Maxwell's plane wave equation. This is kind of out of context, but the way Maxwell derived his plane wave is he's got the B field and the E field are perpendicular to each other. And when you take the cross product of the cross of the E and the B, you get the power in the signal. And I'm going to plot it here as kind of between the two. And so your power, if you look at it signed, goes like this. But if you look at it as absolute power, well, your power goes to 0 when the E and the B cross the 0 line. And then all of a sudden your power magically comes back. So this is inefficient. This loses power and then magically gains it back from somewhere. Where did the power go? I don't know, but this is a violation of efficiency. Either way you look at it. But because we don't have Maxwell's plane wave equation on the punch list, but Maxwell's plane wave equation is derived from Coulomb and Faraday, then Coulomb and Faraday are going to take the hit on the punch list at the end when we take a hit for this inefficiency. The electrical engineering, they have the maximum power transfer, that over a transmission line, the best power you can transfer is 50%. So in other words, over a transmission line, you automatically have a 50% line loss to transmit power. And we're going to use that as a threshold as we go forward. So we consider that we have an electric motor here. Electric motors are roughly 90% efficient as measured from their terminals. But if you have to transmit power over a transmission line, well, you're automatically going to get a 50% loss of power right to the engine. So your overall efficiency of this system is only about 45%, and that's pretty optimistic. So this is what we're going to call a cascade system. And the reason why we have to split up a cascade system is because we're going to use the maximum power transfer as an arbitrary threshold. So any component of a cascade system or a non-cascade system that is less than 50% efficient, it fails this tell. And that means you're required to go in, and that's a potential tell where we need better or improved science. Let me give you an example of a failed system that has to be investigated. So you have this system that from the input to the output only gets you 34%. So there's two ways you can look at this. This has to be addressed one way or the other. So either you need to correct the models or come up with better models that will give you a better technology to give you better efficiency, like going from a light bulb to LED technology would do that to improve the efficiency. Or you need to improve your understanding that there are layers in this system, that maybe that you have multiple layers that are cascaded. And each individual layer is like 70%, so 70% is 70%, or 70% is 34%. If you can argue this, then we probably have a good knowledge of the system and there's nothing to be learned here. So if the individual systems of the cascade system are 50% or better, then this system is compliant and there's probably nothing to be learned. And again, this is just a guideline. It's always best to improve efficiency wherever practical. Historically, though, the best scientific advancement occurs in the first 30%, and the remainder of the improvement is from material manufacturing improvement or merging with other technologies. Like example, internal combustion engines were good, but they got better when we put a computer on there to tune them for basically compensating for all the exterior factors, the humidity, the yada, yada, yada. Okay, so if we use luminous efficiency or luminous efficacy, lighting efficiency, we can see that when we had the candle, we were only 0.4% efficient, very wasteful. Then we got to incandescent bulbs, we were 2 to 5%. Then invented was fluorescent bulbs, those are 8 to 16% efficient. And when LEDs came in, it was 18 to 22%. And now they're saying the theoretical limit of the LED, now this is probably a few years old when I looked this up, is 38 to 44%. But you notice that this didn't break over 50. So is there a cascade system in the LED, or do we not have the theoretical model of the LED correct yet? So that's what this is telling me. There's either a cascade system going on, or we don't have the proper model of the LED yet. We've gotten better, but we don't have the proper theoretical model, or it's a cascade system. Either way, we don't have the correct model because we're below 50%. So, rule of acquisition 20, the poor efficiency tell. Poor efficiency indicates poor understanding. Efficiencies of less than 50% non-cascade fail this tell. Always consider the possibility of a cascaded system when efficiencies are low. And you can read the rest of this on your own. Next, we're going to talk about the speed distance tell. Now, this rule of acquisition originated from the original research on new induction back in the late 1990s. But when I released the first set of the rules of acquisition, I didn't release the original cause that made this rule of action a reality because I thought it was too complicated for people. It probably still is, but I think it's a really good example of why this is a valid rule of acquisition. So what I'm going to do is I'm going to show you the original question followed by the mundane applications that I introduced it first with. So the original question goes by how you view a coil. So what we say in electrical engineering and physics before ethereal mechanics was, well, when I increase the current in a coil, the magnetic field around that coil is going to expand. Say we're kind of charging the coil. Then if I pull out the source and put a light bulb in there really, really quick, let's say with a switch, well, that magnetic field is going to collapse back down to the coil, convert that to electricity, and cause the light bulb to glow for a split second. Okay, that's a collapsing magnetic field. And there's two reasons why this concept, this analogy, this concept of expanding and collapsing magnetic field is nonsense. The first one is that, well, if magnetic field expands and then collapses on itself, that means magnetic field lines must interact with each other. Just like when you blow up a balloon, the air molecules in the balloon react with each other to apply pressure to expand the balloon. And then when the balloon contracts, everything is working back the other way. And you say, well, what's the problem with that? Well, if magnetic field lines interact with each other, that means when light passes through each other, it's got to affect each other, and it doesn't. So magnetic field lines cannot react with each other to cause this kind of expansion and contraction. And ethereal mechanics, a magnetic field is a pure emission. There is no expansion and contraction. So we fixed that in ethereal mechanics. Okay, the other problem with the expanding and contracting model is, well, if it's expanding, how fast does the field go when it's expanding or contracting? But before I get to that, I just want to bring up one little sidetrack point here. Okay, although this expansion and contraction analogy is consistent with experimental measurements, it's useful, it works. It just can't be reality because it requires, as I said before, magnetic field lines to interact with each other. And I'll show that this analogy contradicts other behaviors in a second, but the point I want to make here is that because this thing works, even though it can't be the way nature does it, is representative of the 21st rule, which is representative of the doppelganger tell. Okay, so this is a doppelganger. It gives the right answers, but for the wrong reasons. Okay, so let's go back to the original question. How fast does the magnetic field go? Now, I'm not going to you can read these on your own. And I'm going to just scroll down to the bottom line here. Other people can slowly read these, figure out what's going on. So over here, this is the equation that you come up with. That the velocity of the field, which goes to the right, as this charge wiggles up and down, the faster it goes, the more acceleration and velocity it has. Okay, so you take the acceleration divided by velocity and multiply by the distance. See that? So according to this, the farther away you are, the faster this field moves. That is a speed-distance correlation. That cannot be true because there is a potential point here where this exceeds the speed of light. And that cannot be the case. This is ridiculous. This is another example of how legacy theory is completely out to lunch. No matter how many answers you get that are correct is irrelevant. As we said before, first rule of acquisition. And that's why we need other rules of acquisition to judge the models. Because getting a correct answer is not proof enough that they're good. We need to be able to judge these models other ways. And that's why all the tells of the rules of acquisition were developed. Okay, so we have a violation here of the speed distance tell. Now, the other examples that I came up with are this example here where we thought that the Earth was the center of the universe. Okay, since all the stars rotate the same angular velocity around the Earth, that means the farther stars have to be moving faster to keep up with the same angular velocity. And again, that means that a far enough distance, the stars are traveling faster than the speed of light, and that would be a violation of the 21st rule. And that would, if we had this back then, we could have said, hey, there's got to be some other model than the Earth-centric model because it violates the 21st rule. Then you have Hubble's law. You have a positive correlation between speed and distance. The farther away the galaxies are from the Earth, the faster they're going. This is a clear violation of the 21st rule. And ethereal mechanics has a much more rational explanation. We'll release that in the cosmology series, if I remember to. If not, ask me. We'll make a video special about it. Again, this is one of those doppelgangers. Because it gives us the right answers, this expansion idea, again, doesn't mean it's right because it gets the right answers. And there's another explanation that's more sane that does not violate the 21st rule. And because I don't have Hubble's law in the punch list, general relativity will take the hit for this on the punch list at the end. The pendulum energy guy, if you set kinetic energy of the pendulum equal to the potential energy, then you set them equal, well, you get this equation that says the higher you go, the faster you go. Again, this is the other rule of acquisition, which says derivations lose information. The information in this derivation is lost that the height and the velocity do not occur at the same time. Again, a case where math loses information, leading to ambiguities, and this is a violation of the 21st rule. And of course, we understand this one, so it's not that big a deal. And this is a new violation. So here you have an astronaut with 2 heads and 3 arms falling into a black hole. Now, the reason why my astronaut has 3 arms and 2 heads, because every time I asked AI to make this, it would either make me a correct astronaut but a really sucky black hole, or I'd get a good black hole and deformed astronaut. And so the first time I did it, I had an astronaut with 3 arms. The second time I did it, I got an astronaut with 3 legs. The third time I did it, I got an astronaut with 3 arms and 2 heads. And I said, okay, the company that I'm licensing this AI from is just screwing the heck out of me. Because every one of those instances are just screwing me money. So I decided, you know what, I'm going to live with a deformed astronaut instead of paying through the nose, waiting for, the people that say AI is going to take over the world. I doubt that seriously. It can't even count. How can you take over the world when you can't even count? But again, let's talk about this new violation. So, an astronaut falling into the gravity well of a black hole. As the astronaut moves farther away, distance, yes, its velocity is going to increase relative to the black hole. Okay, that is a speed distance tell. This is a curiousness. Now, if you look at ethereal mechanics, the velocity of the astronaut relative to the medium is actually going to slow as he gets closer to the black hole. And so there's no violation of the speed distance tell because the one body energy is going down, whereas the 2 body energy is going up. Again, as we said in the previous video, the 1 body energy is the more important energy. The 2 body energy is ambiguous, so we don't care about that. I mean, it's useful. We can use it. It's very useful, and we'll still use it. But as far as the theory of everything, we have to be wary of it. Okay, so this gets to the definition of the rule of acquisition 21, the speed distance tell. Suspect any positive correlation between speed and distance, especially if the speed could exceed the speed of light. Now, this is a weak tell because there are legitimate exceptions. So in other words, you have a spinning wheel. Well, the farther you get from the center of the wheel, the faster the tangential velocity goes. That's a speed distance correlation. But then, if you say, well, what if you had a large enough wheel that at the edges of the wheel, it could spin fast enough to exceed the speed of light? Well, what then? Is that possible to build a wheel like that? Okay, so maybe we can strengthen this rule of acquisition into a hard tell by putting in the speed of light requirement. If you have a speed distance that could potentially exceed the speed of light, that's a violation. Because I don't know if you could build a wheel that could exceed the speed of light. That's an interesting engineering problem. Not going to do it here, but if somebody wants to work on it and give a comment, and we're happy to look at a video. Okay, so maybe in a future iteration, we will improve the speed distance tell to move it from a weak tell to a strong tell. And let's go look at the punch list. Now it's hard to see my little red laser pointer here because there's a lot of blood on the screen, but the only tells we have in this video are 20 and 21. The other items we have are traps. Traps aren't on the tells. Traps are just mind traps to avoid. They're not necessarily tells. Now these yellow ones here, I have question mark here because using the efficiency tell on these guys is problematic because I don't know where we have any application where we're deriving power or transforming power with these using real constructs that we could measure the efficiency over what we did with what we used for them in the past. So that requires work. I'm not going to waste time on it because the legacy stuff is bleeding so much, it's just not worth my time. Okay, I'm just going to leave the carcass to rot. It's somebody else's problem. But I'm just letting you know that work needs to be done here to find out if there are violations. Okay, again, ethereal mechanics is doing very good. All of our violations are on the frontier. So we are good to go. If you want to help out this project, become a Patreon member. For passenger level and above Patreon members, you will see all the videos at least a month before they're made public. But what I'm thinking about doing is the cosmology series. I'm thinking about making that only for Patreon members going forward, especially since physicists are basically quitting on us. So why should I give this away to anybody that's not supporting the science? Okay, I'll give it to the people that have supported me over these years, and this is Patreon folks. But I'm going to give that choice to the upper level Patreon members to choose whether they want to eventually make it public or keep it for Patreon only members. I'm going to make a vote, put a vote to the upper level Patreon members for that. This is the repository. Everything that's made public will be put here and linked to here so you can find it in order in a very organized fashion, including whatever software we're releasing, etc., etc., etc. All the papers you will find here as well that are made public. If you want to know how to navigate the repository, the intro video to the YouTube site gives an explanation how to navigate the repository. If you want to get to the YouTube channel, it's www.etherealmechanics.com. Now, your browser is going to say, well, this is not assigned for, it's a threat to security. Well, it's YouTube, okay? If you get there, you're going to go to YouTube. If you don't want to go that way, then just go to YouTube, search for Ethereal Mechanics, and then look for the symbol of the Ring of Fire with Julie in the middle of it. This is the blog site. Great shout out to Sebastian for taking care of this. Again, my JOB is my #1 source of funding for this project. My Patreon members have helped me out tremendously. I think we're at least a year and a half ahead of where I would have been if I was funding it only by myself. So I thank them greatly. And if I could get enough Patreon members, I can get more time, hire more help, yada, 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 then I will definitely take more time to spend here. I'm sorry, I spend all my free time on ethereal mechanics, except for like doctor's visits, vet visits, important things like that. Thank you. No more voodoo physics.